Alright, so here in this video we're going to check out 2.7. This section is called Solving Proportions. A proportion is an equation that states two ratios are equal. Now here in this is what you all have been waiting on for quite some time. It's everyone's favorite cross multiply. Now there are different ways of solving these. For example, this one here could also be solved by simply multiplying both sides by a 5. I'll go ahead and do this from the concept of cross multiplication though, because it'll help out on some of the ones coming up a little bit later on terms of when there's more complicated stuff going on, or like in this one here. So I'm going to go ahead and do these with cross multiplication. I am aware that there's different ways of solving these, and that's true of all types of equations. But here is the gist of what we'll be having when solving for the given variables. We will multiply these two together and these two together. All right, so we will get 15x is equal to 5 times 12 is 60. Then we divide both sides by 15, and we get that x is equal to 4. All right, now, and here's that step there. Can these still be checked like we check all other equations? Absolutely. Plug it back into the original equation. Now, it doesn't look equal yet, but when we recognize that we can simplify 12 over 15, both divisible by 3, and get 4/5, then we see that one side is indeed equal to the other. All right, so this is cross multiplication. Now, we know to use cross multiplication when there's an equal sign in between the two terms, and we are crossing over. Okay? Now, this does not mean that in the future now, if we have two random fractions, say 1/2 times 3/4, this is fraction multiplication. All right, this is where you multiply straight across. Notice there is not an equal sign in between these two. So what we see here today is not us multiplying fractions. These are two fractions set equal to each other. I just want to show that difference there so that we don't start multiplying all fractions with cross multiplication. All right, so we simply follow this cross multiplication pattern, and we get 6x is equal to 40. All right, and then we can divide both sides by the 6. All right, and we get that x is equal to 40 over 6. Now, both of those are even, so we can divide both of those by 2 and get 20 over 3. All right, now it's going to be harder to check this answer because it's a fraction. However, if you plug this in for x and went through all of the processes required to do that, you would land at a true solution. And if you are curious about that, you can come back and try that by hand, or maybe by chance typing that in on your calculator with using fraction functions. Any of that will work. All right. We have two ratios set equal to each other. We cross multiply, and we get 7y is equal to, and then we have 12 times 4, which is 48. Divide both sides by 7, and we get that y is equal to 48 over 7. Once again, this would be a hard answer to check by plugging it back in. Here's what that would look like if you're curious about doing that by hand. If we had 48 over 7, and then we have that over 12, and we're seeing if that's equal to 4 over 7. This here, when we're dividing by 12, that's the same thing as multiplying by the reciprocal. So if we think about 48 over 7 divided by 12, that would be the same thing as 48 over 7 multiplied by 1 over 12. When we do this, you can either multiply straight across or pre-simplify, recognizing that both of these are divisible by 6. And we would get 8 over 7 times 1 over 2. When we multiply straight across here now, we get 8 over 14. 8 over 14 does in fact simplify to 4 over 7, which is what we are supposed to be set equal to. Now that requires some fraction manipulation and knowledge, but you can see there we do in fact get the correct answer. I'll leave that one there that you can come back and try if you're interested in it. So in a standard proportion, A over B is equal to C over D. AD and BC are cross products, and this is what we get when we multiply across here. Using cross products, this is an example of when you can use this to solve for some real information. A box of cereal weighing 354 grams contains 20 grams of fat. Find the number of grams of fat in the recommended serving size of 55 grams. And this is why up at top it talks about this being two ratios being equal to one another. One ratio is 354 grams, and then there's 20 grams of fat, saying there's 20 grams of fat per that. Now you could set this up as 20 over 354 as well, because ratios can go both ways, but I'm going to be setting mine up as total over the grams of fat, which means when I set this equal to my next proportion, it also needs to be the total over the grams of fat. So it says find the number of grams of fat. So since that's what I'm looking for, that will be my X. And the recommended serving size of 55 would go here. All right, to where this is the total amount of my serving size. This is the grams of fat that we don't know. You could have flip-flopped this entire process and you would have gotten the same answer. And that's because cross products would still remain the same. If I switched both of these, to where X was on top and 55 was on the bottom and did the same thing on the other side, we would still get the 354 and X multiplying, and we would still get the 20 times 55. So when we cross multiply here, we get 354X is equal to 20 times 55, so 1,100, and we divide both sides by that 354. We get that the grams of fat will be 3.1. Now let's think, does that make sense? It should. The entire box contains 20. We were eating a smaller portion than the entire box, so our answer should definitely be less than 20. And 3 kind of makes sense if we think about this logically. And that's the power of ratios, of figuring out this is the grams of the box compared to grams of fat. This is the grams in our bowl compared to grams of fat. Cross multiply and you can solve for that. Cross multiplication can apply on multi-step proportions as well. A little bit of a trick on this one though. When I go to cross multiply, this is going to be 7 multiplied not just by the X, but by the X and the 4. And when I set that equal here to this blue component, it will be 5 not just by X, but by X and minus 2. So be sure to set these up as a distributive property. When I distribute on both sides here, we get 7x plus 28 is equal to 5x minus 10. And now we just solve an equation with variables on both sides. I'm going to gather my x's onto this side here. I'm going to gather my constants on the other side by subtracting 28 from both sides. And I get that 2x is equal to a negative 38. When I divide both sides by 2, I get a negative 19. Now let's check this process by going back to the original problem and plugging in 19 for x. When we do that, in this numerator, negative 19 plus 4 is negative 15 over 5. When I do it on this side, Negative 19 minus 2 is a negative 21 over 7. Those might not look equal yet, but if you look carefully, they're both going to turn into negative 3. So that's what tells me this answer of negative 19 is correct. Alright, so I will do one more of that kind of style in the back and then leave you two to try. And then you'll also be able to get extra practice on the homework. Alright, now when I'm cross multiplying here, recognize this is not just 10x plus 2. This is 10 multiplied by x plus 2. I'll set this equal to the other cross multiplication. Now this one's just x times 14. I don't have multiple terms in either of those denominators. So we will get here a 14x. Distribute, we get the 10x plus 20 is equal to 14x. I need to simplify, get all my x's onto one side. I'll subtract 10x from both sides. And I get the 20 is equal to 4x. Divide both sides by that 4, and we'll get that x is equal here to a 5. Now, anytime it's not a fraction, it's very nice to plug our answer back into the original proportion to make sure that we are getting the matching answers on both sides. Okay, so on the left-hand side here in the numerator, 5 plus 2 is 7. 7 over 14 is 1/2. On this side, 5 over 10 simplifies to 1/2. X is equal to 5 is a correct answer. All right. One more thing before you get on to the U-try. This situation right here, we've discussed it in class. This addition and subtraction sign prevents you from canceling these y's. You cannot do this. This is not a valid mathematical step. This y minus 15 and y plus 4, with these having addition and subtraction, do prevent us from pre-simplifying. Same thing with if these shared any factors, I can't pre-simplify here because of the addition with y. And we've discussed that when there are fractions in addition and subtraction in the numerators, it greatly decreases our ability to do any pre-simplifying. So our new go-to, because this looks intimidating at first with y in both of those parts of the fraction, is cross multiplication. Don't forget to do your distributing when necessary, and otherwise these are not too bad at all. People enjoy cross multiplication because it's clear when to do it. When you have two ratios, and ratios just being fractions, two fractions equal to each other, cross multiplication, easy to identify, takes them away from being fractions into just two expressions on both sides. People like cross multiplication, but you do have to remember on cases like this that that's 7 and then distributed to y minus 15. This is 35 distributed to y plus 4.